Hello, everyone. Welcome to our talk entitled Producing Informative Expressions of Left-Right Relations, Differences between Children and Adults in Using Multimodal Encoding Strategies. The ability to use language to talk about space is a fundamental aspect of language and cognition. This brings us to the question that how do children learn to talk about spatial relations? We know from previous research that there are some regularities across many spoken languages for children to learn to express spatial relations. Children learn to use topological relations such as in on under, the earliest, followed by front behind, and learning to express left-right spatial relations appear the latest. Current study focuses on encoding left-right relations not only in speech, but also taking into account co-speech gestures. Describing left-right relations between two entities in spoken languages is challenging for children, and encoding left-right relations between items may not appear until 9 to 10 years of age. Such a delay is attributed to the requirement for a developed understanding of children's own left-right and then mapping of these concepts to other people or objects. However, it has been found that native signing deaf children learn to encode left-right relations between objects earlier in sign, around age 5, than speaking children. The earlier encoding of left-right by signing children compared to speaking children is attributed to the iconic linguistic forms to encode spatial relations in sign. Iconic forms in sign allow for visually motivated meaning mappings between the linguistic form and its referent in the real space. For instance, the most frequent linguistic form used by children is deaf children is classifier constructions. In such constructions, after introducing the lexical sign for the object, signers choose certain hand shapes to represent the size and shape of the objects. For instance, this little girl is using a flat hand shape to indicate the flat nature of the paper and an index finger to indicate the elongated nature of the pen. Moreover, she places these hand shapes on the signing space in an analog way to the real space to indicate the spatial relation between the objects. Alternatively, signers can also use relational lexemes, which are the lexical nouns found in sign languages to represent the left-right spatial relation between the objects by positioning their hands on the coordinates of their body. For instance, this boy is using a lexical sign for right by touching his right arm. Thus, earlier acquisition of left-right by signing children implies that expressing left-right relations might be easier with hands, and this highlights the importance of manual modality to communicate spatial information. When we look at the gesture literature, prior work has shown that children express information about some concepts in gesture before expressing them in speech. Piaget conservation task provides examples of such instances. For instance, in one of these tasks, children are asked to elaborate on the identical amounts of water in two different containers. While solving these kinds of problems, children have been found to use gestures along with their speech, and in these instances, sometimes children's gestures give more information than their speech with respect to their thinking. This is in line with gesture for conceptualization hypothesis, stating that gesture activates, manipulates, packages, and explores spatial motoric information for the purpose of speaking and thinking. Following the findings in sign language acquisition of left-right relations, co-speech gestures might have better access to spatial relations than speech due to one-to-one mapping between the expression in the manual modality as gesture and actual spatial relationship in the outside world. Thus, gesture might provide more information concerning the left-right relations between objects than what speech can express. A promising example from gesture use in spatial communication comes from a study investigating descriptions of spatial layout of hidden items in a room. Researchers found that 8-year-olds rarely encode the spatial relation of items in their speech, but they use gestures to give more information about the locations of items when prompted to use their hands. So, as an interim summary of what we can draw from the previous literature, we can say that children can express information earlier in manual modality than in speech. First evidence comes from native signing children who have earlier encoding of left-right relations compared to speaking children, possibly due to iconic expressions that are signed on the signing space or on the coordinates of their body. And additionally, gestures found to help children to package information for thinking and speaking in general, and for conveying information on the spatial arrangements between objects in a room when prompted to use their hands in particular. What is not known yet in the literature is, do gestures also serve as a medium to communicate about left-right relations between two items by conveying spatial information, which is the last step of learning to communicate left-right relations, in which children need to map concepts of left-right onto other entities. And it does not know whether children use these gestures spontaneously. We tested 26 hearing monolingual Turkish-speaking children and 25 adults. We designed an experiment in which participants were describing pictures of objects in various spatial configurations. In each display, there were 4 pictures, and every picture had the same 2 objects, but these objects were in a different spatial relationship. Ground object was always in the center of the pictures, and figure object changes its location in relation to the ground object. Within one display, target picture to be described was pointed by an arrow. We have 84 displays in total, and experimental displays consisted of pictures of items in left-right relations. We believe this task is one step more challenging for children, in which they have to zoom out of their own left-right and into the spatial relation between the 2 items in the stimuli pictures. In the task, participants are asked to describe the target picture that is pointed with an arrow to the Confederate addressee sitting in front of them. Addressee has a tablet with the displays and makes a selection based on the participant's description. Participants were aware of the fact that addressee has the same display without the arrow. There were no explicit instructions to use gestures or not. Addressee was a Confederate and be present to ensure a communicative nature for the task and set natural needs for informative descriptions. We defined informativeness of the description from the perspective of the participant. We focused on whether information conveyed in the participant's description provide uniquely referring expressions that distinguishes spatial relation in the target picture compared to other potential reference pictures in one display. Moreover, in our definition, we are agnostic to whether this is picked up by the addressee or not. Following the evidence in the literature on learning to encode left-right spatial relations between objects, we predict that, in speech, children will be less informative compared to adults. Additionally, we predict that children and adults will be informative in different ways. Based on the literature on children's ability to express some concepts in their gestures before expressing them in speech, as well as the sign language literature showing an earlier acquisition of these concepts in sign, we predict that children might be informative when both modalities are combined. And adults will be informative already in speech, and their multimodal encodings, if any, will be redundant. So, to test our first prediction, we coded participant speech, and we found out 2 ways of describing, using either left-right spatial terms or a general term site. We grouped these descriptions into 2 categories, informative speech and under-informative speech. In informative speech cases, they consisted of descriptions with left-right spatial terms. And under-informative speech cases consisted of descriptions with site. And here, site is under-informative because it does not convey the exact spatial relation between the 2 entities. And second, because in Turkish, side can be used to refer to any side of an object, including its front and behind. Therefore, descriptions via side does not differentiate between left, right, front, and behind within one display. So when we tested whether adults and children use these strategies differently, we found the following, but let me first walk you through this graph. The y-axis shows the proportions of using informative speech in describing the spatial relation between the items. So higher values indicate more left-right use and lower values indicate more side use. The width of the violins represent the density of data distribution and length of the violins depict the range of data points. And we have dots representing the mean. But we found that children use informative speech less compared to adults. In order to investigate our second prediction, we coded spontaneous co-speech gestures produced by children and adults that convey information regarding the location of the two items or the spatial relation between the items. We did not take into account other type of gestures, such as beat gestures. We did this coding per description and regardless of the type of speech used in the description. And we found that both children and adults use these spatial gestures. Children use them in 64% of their descriptions, and adults use them in 48% of their all descriptions. Let's see some examples. We have one-handed directional gestures indicating the location of one of the items, such as this pointing gesture. And we have relative location gestures. These are two-handed placement gestures indicating the relative location of two items in gesture space. Later, we group these gestures with speech and we form multimodal encoding categories. In the first category, we have informative speech, left or right, with spatial gestures. Here, gesture use is redundant to convey the spatial information between the objects because speech already conveys it. In the second category, we have under-informative speech through using sight, coupled with spatial gestures. Here, the gesture used is complementary to the information conveyed in speech. With the use of gestures, participants increase the informativeness of their description. Later, we analyze how these different types of multimodal descriptions are used by adults and children. When we compare the descriptions by adults to children in terms of these two informativeness types, results show an interaction between age group and multimodality type. That is, children and adults use these multimodal strategies differently. Children use complementary gestures with under-informative speech more than informative speech and redundant gestures, whereas adults use the opposite. They use informative speech with redundant gestures more compared to complementary gestures with under-informative speech. Later, we zoomed into the different types of gestures produced by children and adults and whether these types differ between children and adults. So when we look at the types of gestures produced by adults and children, model shows an interaction between gesture type and age in which children use spatial gestures indicating relative location between the items more than single location gestures, whereas adults use the opposite. So our findings show that children are less informative in their speech compared to adults, and they prefer multimodal encodings with complementary gestures, mostly using two-hand placements of relative location of items. And please note that this pattern is unique to children and rarely present in adults. When adults use co-speech spatial gestures, they mostly use single location gestures redundantly to accompany their already informative speech. So our findings provides new insights to the literature on learning to encode left-right relations in which children could map concepts of left-right onto regarding two items through complementary gestures before communicating them in speech and doing it spontaneously. That is, they are not prompted to use gestures in the study. This finding is important because it is the last step in learning to communicate about left-right spatial relations between items in which they have to zoom out of their own left-right and into the spatial relation between the two items. And gesture used in describing left-right relations between two items parallel the findings found for early acquisition of learning to encode left-right in sign languages. The parallels between sign and gesture development are not surprising due to the overlaps in types of representations between both forms, sign and gesture, of manual communication. Moreover, our results provide more evidence to gesture for conceptualization hypothesis, in which gesture argued to activate, manipulates, packages, and explores spatial motoric information for the purpose of speaking and thinking. These processes help children find ways to incorporate missing information in their speech while describing left-right spatial relations, and children use gesture as an index for conceptualization. Moreover, gesture can create an iconic description of the real space after all, and children easily express real space by mapping it onto the gesture space through their hands before speech. It is also possible that children's two-handed placements gestures to depict the relative locations of the two items help them visually think and possibly ease the cognitive load for the abstract concept of left and right, that is utterly symmetrical. Thus, it provides an exploratory strategies to describe the spatial relations between the items for children. Or that children use these gestures out of communicative intent, in which they might be expressing the spatial relation between the items through their hands, as they could not be informative in their speech. Yet, of course, our study was not set to disentangle these questions, but we believe these are very important questions for future research. Finally, previous research on children's pragmatic and cognitive development have a tendency to focus on speech only. We believe that our findings also highlights the importance of considering children's multimodal encodings in assessing their pragmatic and cognitive development. So, in conclusion, although children do not yet encode left-right relations verbally, they encode the relative locations of two items in gesture when speech does not provide enough information. First of all, I want to thank you for listening, also on behalf of my co-authors. Next, I want to thank our research assistants. This study would not be possible without their efforts, and I want to thank our funding agencies. Thank you.